in this first exercise, we consider two different systems of moist air that will be mixed and form a third system. The first system, number 1, has a mass defined by the mass of dry air of 1 kilogram and a relative humidity of 60%. So it means that the total mass is of course higher than 1 kilogram, because to this 1 kilogram of dry air we need to add the water vapor, but it's still defined by the mass of dry air. Then we know the temperature, that is 25 degrees Celsius, and we know that we can read on the diagram the moisture content and the specific enthalpy of this air. Then this mass of air is mixed with the second mass of air of 2 kilograms of dry air. We know that it's saturated, so the relative humidity is 100%. The temperature is now 10 degrees, and we know we could read on a diagram also the moisture content and the specific enthalpy. So now we know that these two systems are mixed, and in the mixture the system is homogeneizing, and this would lead to a third system that is called 3, with given mass, given relative humidity, given temperature, given moisture content, and given specific enthalpy. So how do we do to define exactly the states we have for system number 3? Then we do balances. We know that when we do a mixture, this is a closed system, so we need to keep a balance in the mass, and we can do it separately for the mass of water and for the mass of dry air. And also during a mixing process, there's no exchange of energy with the outside, so we know that there will also be conservation of the specific enthalpy. So we can write the balances. So for the mass balance of dry air, as the mass of each system is expressed in mass of dry air, it's simply M1 plus M2 is equal to M3. Concerning the mass of water that we have in each of the system, the mass of water is the product of the mass of dry air by the moisture content, because the moisture content is the ratio of mass of water by the mass of dry air. So we get M1 X1 plus M2 X2 is equal to M3 X3, because the water mass that we have in system 3 is the sum of the water mass we had in system 1 and 2. Similarly, we can do the balance of enthalpy. So the enthalpy H is defined in energy per unit of mass of dry air. So if we want to do the balance of enthalpy, we simply multiply the mass of dry air by the specific enthalpy for each system. So we have M1 H1 plus M2 H2 is equal to M3 H3. So now if we just read X and H on the diagram, we can calculate easily what are X3 and H3 in order to properly define what is the state of the mixture. However, that's not what we are trying to do here. What we want to do is to solve graphically our problem on the Carrier diagram. So for this reason, we'll go a bit further. We can simplify these three equations by replacing M3 by M1 plus M2, and in that case we can write then X3 is equal to X1 weighted by M1 over M1 plus M2 plus X2 weighted by M2 over M1 plus M2. And similarly, we can also write the same for the specific enthalpy. H3 is equal to H1 weighted by M1 over M1 plus M2 plus H2 weighted by M2 over M1 plus M2. In that case, we can recognize that we have exactly the expression of a barycenter. 3 is the barycenter of 1 and 2 weighted by the mass from each of the systems 1 and 2. So we can say then 3 is the barycenter of 1 and 2 in a XH, or moisture content enthalpy diagram.